So, fair warning, and disclaimers first. This is really a talk about the experience I've had on a particular project in trying to have kind of very tightly integrated LabVIEW systems with traditional web systems, a web UI front end, and some back end stuff as well. So really this is kind of a mental dump of kind of where I found the limits of LabVIEW to be, some of the technologies I found to complement LabVIEW well, and really put out a few questions there of, well, is this something we want to keep doing? Is this something we want to do a lot of? In which case, where are the gaps that we need to fill, or where do we need to know to sort of move on to something else? So the system that I'm looking at is kind of a typical compact reader system. It's a power monitoring system for National Grid. Connecting one is easy. Connecting many, and we're going to end up with about 135 in the field, is a lot more difficult. This is the National Grid that we're measuring, so that's not 135 around a building like this. That is 135 around England and Wales. So we need a way of grabbing all that data and presenting it to the user, in this case the power systems engineers in the design team at National Grid, that they can understand the data, analyze the data, and ultimately what they want to do is be able to make decisions going forward about how to change the grid, how to adapt to any challenges that they show. I mean, it should be fair to say this is all power quality monitoring, basically. So I like it. They refuse to call like wind turbines and solar farms clean energy, because from an energy point of view, it's very dirty. It has lots of harmonics because it all pushes out DC and has lots of switching to convert it to AC, which causes their components to heat and potentially fail if left unchecked. And so basically it's how do we bring all that data together, and I've sort of given away the answer really is the web, the internet. You have to have some sort of a meme if you're talking about the internet. And to be fair, in this case, what I'm talking about is not so much the World Wide Web, although I have other systems kind of utilizing that as well. This is all going to be on a kind of countrywide private network, if you like. But nonetheless, it's the same challenges. It's multiple distributed nodes, unknown network infrastructure kind of between them. Unknown because it's complicated as much as someone couldn't sit down and explain to me exactly what it all is. But it's that kind of unknown. And then the other thing is the interoperability. Is the other big thing with the web. It's about the fact that it's how can we design a system that we know will work for every end user, or will work through every network switch. By what I think really makes the web tick in a lot of ways is it's these kind of fairly loosely coupled standards. So we have standards for the communications with things like HTTP. But HTTP doesn't tell you anything about what that content should be. That's HTML. But the two work together well and have become a standard way of moving stuff around the web, such that we probably all have different web browsers installed and can still load ni.com or whatever it might be. And these standards also solve some of our networking issues. Every router in the world at this point knows how to deal with HTTP packets or FTP packets. You're never going to make an IT admin nervous by saying, I want to put some HTTP over your network. Whereas if you go to them and say, I'd like to use this custom protocol running on this high numbered port that's from this other company, they tend to ask a few more questions. And of course, now we have the Internet of Things, which, for the definition of this, a compact reader can be considered a thing. We've now got not just our standard web servers and our standard clients, but we need other devices to talk as well, which introduces its own challenges. And it's probably where LabVIEW is going to come in. In fact, well, let's say for the purpose of this talk, it's definitely where LabVIEw is going to come in, because that's where LabVIEW, really sits strongly. So in this I could say, interconnected web of things, which is kind of the same point of saying the web. In these various standards, where does LabVIEW fit? So devices, I'm going to skip over. I think we can all agree LabVIEW runs very well on devices. It talks to the real world very well. And this is really going to be LabVIEW's place in the Internet of Things because, well, we've been doing these hard things for 20 odd years with LabVIEW relatively successfully. And I think it's because LabVIEW sits at this sweet spot of kind of being able to do good processing, great interfacing with the real world, but also that communications backend is a critical thing. So on my last slide, I jumped over a little bit quickly. I went out and said, what are IoT hardware devices? What is out there? And the thing that comes up is things like Arduinos and Raspberry Pis, which have that often don't quite suit all of these areas in one go. Arduino is very well known for being great at I/O, but it doesn't really have the processing power to deal with encryption technologies or sending secure network data. The Raspberry Pi is somewhat the opposite. It's used a lot for I/O, but I wouldn't really say it's ideally suited to it, although they're improving things all the time with it. We have a few digital ports that you have to read through through the Linux system. The LabVIEW, I think, my interpretation sits at this sweet spot. We can do all of these three things very well in LabVIEW without having to switch technologies to something more appropriate. So what it can do to integrate with these things, well, the first thing is the HTTP libraries. LabVIEW can talk HTTP. It can be a server with some of the limitations I've discovered, which I'll come back to later. And it can be a client. It can actually, so I have to remember my slide order from a while ago, I'll come back to that. It can do HTTPS very easily. A big flaw with the FTP libraries a few years ago was as soon as everything went secure, it still didn't support it. And the same thing with the email libraries, which I think were fixed last year, but have been in since version 6, but they can never do security. But HTTP libraries went in, and they've had that, I think, from the start. And obviously security is going to be paramount when you're using the open web. The other thing is the content interoperability. So JSON is widely becoming a standard. You really get two major standards, XML or JSON. That's what most stuff seems to use, most APIs seem to use. I've gone for a preference of JSON because, as I'll talk later, all of my endpoints are JavaScript, which deals with JSON very nicely. It's also a little bit more cross-platform in the LabVIEW world. A lot of the native XML palettes in LabVIEW use .NET underneath. But there are other palettes that get around some of that when you go to the platforms, but that's a problem with XML. There are a few libraries around for this. I personally have used James Powell's library a lot. I keep pushing it. It's a really good community-driven project on Lava. Until I started trying to put through thousands of points at once, it was always fast enough. And that's a reasonable limit. I'm willing to go for that because it's a bit of a stupid way to use JSON anyway. But
one of my customers gave me a 78 megabyte file that they had produced overnight. So it doesn't work properly. I'm like, it's not working properly.
Yeah, that's where I try and convince people. CSVs is the other one, fun one with that. This won't open in Excel. Well, no, it's huge. So JSON, there's some great libraries out there. It makes it very, very easy to deal with. And quite frankly, if it's a limited set, the scheme is very simple that you could start to do stuff yourself if you, which is what I had to do in the really high performance bit. But it's JavaScript object notation is what it stands for.
It's really simple that you can parse it yourself. Because the only point of JSON is the rules are like just 1 page long.
Yeah, yeah.
Well, it is like 1 page long. It's not XML, which is really, really complicated. It's just this. I mean, I could do this in a day. And the start bit you can't do. Yeah.
Dropping XML makes me happy. you can tell you don't like something. I'm not going to use XML.
I had to use XML recently. It's like, oh my god, this is to get the node and then why can't I just get the value?
Yeah. but it's human readable. But I've never really agreed with that argument.
There's computer scientist readable.
Yeah.
They're very separate from humans.
One thing that I could talk about a whole session for, so I won't, but you've got to think about these things, is security. It's going to come up more and more, especially if we're using the open web. It's got to be built in from the bottom up. This is an area that actually LabVIEW is a little bit better at than I had appreciated in some ways. So I already mentioned the HTTPS support is in there straight away. HTTPS gives you a couple of things. It encrypts everything in flight, which is obviously an important thing for people sleeping in on data. It actually gives some level of identity protection as well. If you have a server, you give it a HTTPS certificate, and then your clients go and check that certificate matches what they would expect from that server. There's a couple of mechanisms for that, but you can use it to some extent as I am talking to the correct server as well. The other thing we need for security is good cryptography support. We need to be able to do there's things like different hashes. So, for example, if you're storing a password, you don't want to store it in plain text. You want to store it as a hash. There is actually, again, a library on Lava, and I forget now, because I haven't prepared this as well as I did for the CLA Summit, who wrote that. I think it was either Tom or Rolf K on the Lava. I think so, yeah. And this supports some kind of basic hashing features that I've used for some of the communications as well. So there is actually a fairly decent infrastructure there. You mentioned SSH. That's one thing I'd love to understand a little bit more, how we can bring that in at a bit of a lower level, because so much stuff depends on SSL. So SSH sits on SSL, so does HTTPS. I'd love to see if there's something we can do with that, but there's no libraries for that yet. If anyone's, like I say, feeling particularly like defeating themselves. Just talk through all that. So what does it need to do, or what would be interesting to do, is some of these as well. So one thing that I think we've got to do as a community is keep on top of some of the newer standards that are emerging, especially from the kind of IoT space, the Internet of Things space. One of those is some newer protocols for dealing with more sensor-based data. So hopefully really useful to us in the LabVIEW world. Actually, when you hunt around on the community, quite a few of these, there's at least a first stab at getting them working. One that's come up a lot is MQTT. In fact, I was looking at it again this morning. A lot of kind of IoT server-side software supports this protocol, and there is a library on the community for doing this from LabVIEW now.
It doesn't look that difficult to do yourself, right?
No, it's a very simple low-level protocol. It's designed for low-power devices, and I think I definitely want to use it in a project. I can't use it in this project because there's some security restrictions on the firewalls, but I'm definitely going to be looking at it going forward. On the right kind of represents updating. If we are going to build in security, there's no point in building a secure device that you cannot then update, because one simple hole gets found and the device is insecure. All your hard work is undone. We need to think about, from the start, how are we going to update these devices should we need to. A really nice example of this is the router companies getting a lot of trouble because of, so do you remember Microsoft Live and PS4 network, or whatever PlayStation 4 got taken down on Christmas Day? That was actually a botnet of routers, because the router companies, basically all their routers are horribly insecure. They don't have a suitable way of updating the firmware remotely. They have very predictable default settings. And so Lizard Squad, or whichever hacker it was that did it, took over your routers and used your routers for an attack. And they're under a lot of scrutiny now as to, well, how are you going to fix these problems going forward? There's some additional technologies that are really interesting as well for us in particular. This one is WebSockets. Steve mentioned, actually someone has got a good implementation of this. Really what this is a way of doing TCP as if it was HTTP. It's actually probably the simplest way to describe it. You initially handshake through HTTP, and then you can just get a standard TCP stream. It means we can stream directly to the browser. It also means, again, we bypass. We work with the routers and network infrastructure's understanding of how the web should work. WebRTC is kind of an extension of that, and it's actually, I think, something really could be really exciting if there's an easy way to get it into LabVIEW. This actually says, so in this case, in WebSockets, you have a server and a client, and the server and client have the stream between them. But for example, if you want to do video conferencing, that means you have one from one client to the server and then back to the other client. You have two connections to manage and deal with. WebRTC, the server kind of sets up a connection, so you end up with a direct connection between clients. So I can imagine if you wanted to end up with a compact rear in the field, and you wanted an end user who wanted to stream data from that, live data, this technology could be amazingly powerful. It means it's early days, but if it's well adopted, it means the network infrastructure will then deal with that scenario, which right now is nearly impossible because something is always blocking a port coming in. It's very hard for a client to receive connections over the internet. So that one could be really interesting. Obviously, the fella on the left is our hackers. I've kind of talked about that already, really. We've got to be conscious of. The simplest advice I was given is it's kind of like a marketing profile, but for hackers in some cases. So if you've ever done any marketing work where they say, right, you need to sit down and decide who your users are, why they're interested, where are they going to come and look at, so you can kind of tailor to their needs. I got told exactly the same thing about hackers. Think, who's going to want to access this information? Why are they going to want to access it? How sophisticated are they? Where are they in the world? Being conscious of these guys is difficult. And I think we need to, there's some good stuff up online already about secure and compact rears, and we just need to kind of stay abreast of that and understand that. So, I had my bits of the system, and I'm going to talk a little bit about the technology in the different areas and where I think LabVIEW can work. I took out the client slide, I think. Now I remember I should have checked first. Clients, I'm not going to talk about too much. I think everybody knows where LabVIEW stands with that. It doesn't work in the browser. Despite some attempts in the past, there's no browser support. You've got to use standalone LabVIEW's application to do that right now. So I'm actually in this project dumping LabVIEW on the client side. Everything's going to be through the browser. It's just how users nowadays expect to be able to interact with these systems. And the technology for visualization is just much richer. There's a lot more options for us in the browser. The server's the more interesting bit.
Are you going to write the code in the browser yourself, or are you getting someone else to do it?
I've actually done most of it myself. I've sat down and learned JavaScript for the last year.
What's the learning curve?
I didn't find it too bad. I found JavaScript, it's an easy language, but that means easy to get into trouble. And let's be honest, I've only been doing it for a year. I may not know if I've got into trouble yet. But no, I found the learning curve to be pretty good. There's a hell of a lot of resources. I mean, that's the benefit when you go to something quite as mass market as that, to help you get there. Obviously, it's text-based. It's different. JavaScript is basically event-driven. So almost all the code is, when this happens, do this. Which I actually found quite a natural way of working coming from LabVIEW, although LabVIEW isn't event-driven. We use that style of working quite a lot. So I found it quite straightforward. I enjoyed working with it. I don't want to commit to it and say everybody will find it really easy and just take to it. But it's certainly not as significant as going to like Java or something like that.
It's the second or third most popular language.
Yes, it's crazy popularity.
I always think it might not necessarily be the best, but popular is always a good thing. If most people are using it, that means you get the most resources.
That's it, the amount of help out there. And there are like 4 or 5 different major application frameworks to make life easier. And it's...
That's the problem, I don't want 4 or 5, I want 1.
Well, true, yeah, but then we have, there's something to deal with all the different cases. But I think the point is it's designed for you to come in, you can get in and start running doing like a full OO crazy massive application, or you can use a high level framework that lets you just do a quick event on what you need to. So there's kind of different levels of engagement that you can take with it. But yeah, it's not easy, but it's easier than quite a lot of things out there. So for the purpose of this, I'm defining a server as something with some storage of information, something that's for our kind of IoT use case is going to take updates from the device, data from the device, and serve the client's requests for data or information. And this is kind of the gray area for LabVIEW. We know LabVIEW runs on devices. I've somewhat written off LabVIEW on the client side right now. But on the server, well, it's desktop applications. LabVIEW has the technology to deal with all of these scenarios. So where is it useful and where isn't it?
The question with the server is how many requests can you handle a second?
This is it.
Some other computing.
And that's an important thing, actually. So the first thing to know about the LabVIEW web server is it is designed to be embedded. It is not designed to sit on a server and yet handle 10,000 requests a day or however many. So that was kind of that's the first thing to be aware of. It doesn't have anything special for serving up static pages, although it can do. But it's actually something called AppWeb by a company called Embed This. You know, NI have licensed that technology from them and embedded it. I'm pretty sure that's openly on the NI site somewhere. It's I mean, you can tell because when you ping it with a request, it comes back and says, this is Embed This AppWeb server. So I'm not telling you anything you shouldn't know. But for it to scale, you have to be conscious of a few things. It only has up to 8 worker threads. Here I've put by default because I was playing with, well, it's in the configuration file. Can we muck about with that? The short answer I then got told at the CLA summit was, no, NI overwrite or LabVIEW overwrites the config file every time you rebuild it. So you can either be very disciplined and remember to change it every time, but we all know how that ends. So let's just say you're limited to 8 worker threads. So if you're going to get a lot of parallel requests, there's going to be a limitation there potentially. The other thing is...
Can each worker handle 1 request at once?
Yes, yeah. Yes, it is blocking, yeah. So the thread is going to be taken, I haven't worked out exactly how it looks, but essentially your LabVIEW VI that represents that URL is going to take that thread until it's done. It's going to be sat on that thread until, as if that VI is running on a thread. So I don't think, if you went off to a database or something, I don't think it then frees that thread or anything like that. It takes that up.
So there's no way to get the worker thread into some regular LabVIEW, and then is it stuck waiting until it replies to the request?
That's an interesting question that I haven't tried, because you do now have one of the big advantages to using LabVIEW's web server is you can talk to the rest of your LabVIEW application using queues, notifiers, any inbuilt method. So in theory, if you wanted a simple endpoint and then you wanted to fire off that request to your main application to do something, you have the mechanism to do that. My suspicion is, though, until you actually send a response, that worker thread is kind of taken up. Obviously, if you want to handle parallel requests, you have to make sure everything is re-entrant. Just something I'm increasingly thinking in LabVIEW should be easier to know than it is. Because I get caught out by that quite a lot. And I've seen very good LabVIEW programmers get caught out by that, going, oh, let's just set the top to re-entrant, and no, everything underneath is re-entrant. Now we have to go back and check everything.
So you have a shared re-entrant API and make a subway, create a subway in it. It starts off as shared re-entrant itself. And then you go start to debug it. Like, why am I not seeing anything? And you change it to a non-linear yourself.
Yeah, it's a funny model, though I don't have a solution, I will say. I don't know what the right way is to do it, but yeah, it feels like that's a bit harder than it should be. So, I mean, those are kind of, we actually, through all of that, really covered, I think, a lot of the points. The in-process communications for the LabVIEW app is incredibly powerful. And that's the original reason for using LabVIEW in this case. What we're actually doing, so we get historical data from these devices on the National Grid project, which gets shoved straight into a database. But we also have live data. And right now, this server is taking that live data in LabVIEW, building an in-memory table in using like DVRs and variables as a lookup for them. And then our LabVIEW web server can just talk directly to those DVRs to pull the data out. So that's incredibly powerful ability. The other thing is obviously single development environment. We've already talked about JavaScript. Any other tool, you need to go and learn a new language. And that is not a small undertaking, especially if you're under any sort of time pressure. I've got a couple of concerns. Scalability is still a question mark. To be fair to it, it did better than I expected. I set up a test that I was wholly expecting to break, and it didn't. So that was okay. But it's going to have limitations. It simply isn't designed as a server, web endpoint. It's designed to sit on an embedded device where you're going to have one or two clients, really tops. Very rarely going to get lots of parallel requests. So we've got to have a question mark about that. It's also a bit too much of a black box for my liking at the minute. I was saying there's a bug where, well, it's not a bug. It's a combination of configuration items. But we can't change it because LabVIEW will overwrite the configuration file every time. And it's very hard to go in and debug it because it's kind of encapsulated in LabVIEW as a process. So I'm actually quite heavily going towards, and in fact, since I did this presentation originally, we are going to use Node.js now for this endpoint to complement LabVIEW to deal with this. I don't expect you to read all of this. The short version is Node.js brings JavaScript to the server. So there are traditional server-side languages. You might use Java or PHP or something like that. Node.js allows you to write server-side applications in JavaScript, which I'd already learned for the client side. It's an event-driven, non-blocking I/O model. What that means is instead of filing for a new process to handle every request, it takes in a request as an event. So it's still that kind of event model of programming. Then when you hit, say, a database item where it's got to go off and wait for something to happen, it sets that going, goes back and handles other requests until that database comes back and says, yes, I'm ready with your data. Now you can complete the other request. So it's a model that I like, I've enjoyed using. The question is kind of really how to run that alongside LabVIEW. So the current model that we're kind of going with is we're going to keep LabVIEW for our device management. So LabVIEW is still going to talk to the devices. It gives us more options in communication, obviously, because LabVIEW's a LabVIEW then, or less options, perhaps is the better term, the built-in options that we have in LabVIEW. It's very good at handling all of that. It's still going to pull all the data into the database because it's kind of a big chunk of time work that then doesn't detract from the web server and the clients outside. And then Node.js is going to deal with the queries. It's going to query the database. As I say, it has this very nice, efficient mechanism of dealing with that. All we've got to figure out is how to make the two talk to each other. And that's the current process I'm going through at the minute. There are a number of kind of cross-process communication mechanisms that Node would support, often going through message brokers. So there's RabbitMQ. We could use MQTT on the server, or there's something called ZeroMQ as well, which may work. So I'm trying to kind of establish and understand which are the best ways to do that. And that's probably the thing to report back on, is how to make these interoperate well. But fundamentally, this is the architecture we decided to go with, because we just think on the web side, it's Node's core job. If we want to go in and change something, it's there, it's documented, it's available to us. Right now, LabVIEW, it just feels a little bit too much like a bit of a bit on the side that is hard to really dig into a lot of detail. So that is kind of my explorations around LabVIEW and the web so far. It will all change in the next year, I'm sure, as I suddenly learn the next golden bullet or whatever happens to come along. But I think the thing is, the web is here for good. This is it's setting the standard for the way people expect to interact with software. I think at the end of the day, nowadays, it's quite unusual. You know, I run my business almost entirely in the browser at the minute. There's so much cloud software out there. People know how to use it. Even my dad, who's a complete technophobe, can get on and watch videos on YouTube. If you ask them to install an application to do it, it would be a totally different story. So we've got to decide how much we want to interact with that, decide how much to push. There's a lot of elements that actually LabVIEW is pretty ready for this, but we need to keep an eye on either complementary environments that can help us fill that up, or understand, well, maybe what can we add to LabVIEW to improve this. That's all I've got. Any questions? Cool. So yeah, feel free to grab me at any time. I've read a lot around this now. I'm more than happy to share any thoughts. Security is also another interesting one, but as I say, that's a whole topic in its own right.
Thanks, mate. Very good.